In this problem, we have a system of equations, and in this particular instance, we're going to solve the system of equations with the graphing method. So the first thing I need to do if I'm going to graph is get them into slope-intercept form, y equals mx plus b. So in the first equation, I know the x is on the wrong side, so I'm going to subtract x from both sides of my equation. I'm going to get 2y is equal to negative x minus 4. And then I'm going to divide the entire problem by 2 to isolate the y. So I get y is equal to negative 1 half x minus 2. So in this problem, my slope is negative 1 over 2. My y-intercept is equal to negative 2. The second one, it's almost in slope-intercept form. This particular problem, the 4 is the only thing on the wrong side, so I'm going to divide everything by 4. So I get y is equal to 3/4 x plus 3. Here my slope is 3/4. My y-intercept is equal to 3. Okay, now that I have both equations in slope-intercept form, I'm going to graph both equations on the same coordinate plane, and then I'm going to look for the point of intersection. So I'm going to start with this one that I have written in blue. So we're going to start at negative 2, and my slope is negative 1 over 2, so I'm going to down 1 over 2, put another point, down 1 over 2 again. I'm going to keep going until I run out of graph paper. Then I'm going to go up 1 and back 2, and complete the graph in the opposite direction. That will allow me to make a line through those points. Then I'm going to move on to the red graph. So I'm going to start at positive 1, 2, 3, go up 3, 1, 2, 3, over 1, 2, 3, 4, and go down 3 and back 4. Okay, and make a line through those points. Okay, again, what I'm looking for is the point of intersection between the red line and the blue line, and it crosses right on the x-axis, so my ordered pair is at 1, 2, 3, 4, negative 4, 0. So the point of intersection between both of those lines is at the point negative 4, 0. And if you wanted to, you could go ahead and check to make sure that's the correct answer by taking both original equations. So x plus 2y is equal to negative 4, and 4y equals 3x plus 12. And everywhere I see an x, I'm going to plug in the negative 4. Everywhere I see a y, I'm going to plug in a 0. And I'm going to simply solve them out to make sure both sides of the equal sign are equal. So negative 4 plus 2 times 0 is negative 4 plus 0 equals negative 4, or negative 4 is equal to negative 4, which checks out. The other equation, we have 4 times 0 is equal to 3 times negative 4 plus 12. 4 times 0 is 0 equals negative 12 plus 12, or 0 is equal to 0, which also checks out. Okay, so my solution to my system is negative 4, 0.